So in this video, we're going to be going over section 7.3, which is mole, gram, or gram to mole calculations. We are also going to learn how to solve law of conservation of mass questions. Okay, so the first part we're going to do is looking at this new formula, of course, on table T under mole calculations. So this formula says that the number of moles equals the given mass divided by the gram formula mass. Okay, so we're going to start out by having a given mass, so a mass that is given to us and a certain compound, and then determining how many moles that are actually, how many moles that is. Okay, so a given mass is a mass that some sort of scientist has measured or has calculated, and it can be given in the question. Okay, so we can say what the scientist measures. Our gram formula mass, or our GFM, okay, or molar mass, is going to be the mass that you calculate when you use the periodic table and you add up all of the atomic masses of the atoms that are in a certain compound. Okay, so we already had a bunch of practice with that. Okay, so this is when you're going to use your periodic table and add all of the masses together. Okay, so we're going to use these two bits of information to figure out what the number of moles is. Okay, so the first example is how many moles are in 39 grams of lithium fluoride. Okay, so this 39 grams that they give us, it's a given mass. So the question gives us. So they measured 39 grams on a balance of lithium fluoride, and we want to figure out how many moles that is. Okay, so we can do that because we have the measurement. We measured the mass of this sample, and we also know that it's lithium fluoride. Okay, so we are going to, first step would be to find what the gram formula mass of lithium fluoride is. So you're going to take out your periodic table. We have lithium and we have fluorine. Okay, so there's just one of each of these atoms. It's a 1-to-1 ratio. Okay, so we're just gonna have to add the two atomic masses together. So lithium has an atomic mass of 6.9. And fluorine has a atomic mass of 18.99, so we'll just round that to 19. So adding those two together, we get that the gram formula mass of lithium fluoride is 25.9 grams per mole. Okay, so now we could just plug everything into this formula that's on table T. So our given mass was 39 grams. Our gram formula mass that we calculated of lithium fluoride is 25.9 grams per mole. So we can just plug this into our calculator, divide 39 by 25.9 to get 1 point. I'm just going to round it to 1 decimal place. To get 1.5 moles of lithium fluoride. Okay, so you're going to try these out. Okay, now sometimes we have to calculate what the mass is given the number of moles and the gram formula mass of the compound. Okay, so it's basically we're just swapping what we are solving for. Okay, so in this question, we're told that there's 4.50 moles of potassium hydroxide. Okay, so we're given the number of moles in this case, And because it says potassium hydroxide, we know that we can always find what the gram formula mass is using our periodic table. So we're going to do that part first, finding the gram formula mass. So we have potassium, oxygen, and hydrogen. We have one of each of those atoms. The mass of potassium is about 39. The mass of oxygen is 16. And the mass of our hydrogen is 1. And again, I looked these up using my periodic table. So we're going to add 39 plus 16 plus 1, and we get that the gram formula mass of potassium hydroxide is 56 grams per mole. So now we can just plug everything in. So we're just going to plug it in exactly how it's set up on table T. So our number of moles we can just put over here on the left. Okay, so we have 4.50 moles. Then we're going to put our gram formula mass on the bottom. So we can put our 56 grams per mole here. And then we're solving for X, which is the given mass. Okay, so for this one, we're just going to have to cross multiply to get X by itself. So we're going to multiply those two numbers. So 4.5 times 56 will give us that the given mass is 252 grams of the potassium hydroxide. Okay, so using the same exact formula, you're just plugging in different bits of information. Okay, so the second part of this section is about the law of conservation of mass. So we talked about this already. But since there is a conservation of mass in all balanced chemical reactions, we can determine the mass of the products given the mass of the reactants and vice versa. So for example, this question says determine the mass of calcium oxide produced if 200 grams of calcium carbonate decomposed and produced 88 grams of carbon dioxide. Okay, so that's a lot of different kind of fancy words. We have the word produced, we have the word decomposed. It doesn't really matter. What you have to recognize is it's asking for the mass of some sort of substance in this chemical reaction, and it also gives you the mass of other substances in the chemical reaction. So for the law of conservation of mass to be true, we want the left side and the right side to equal each other. So I just split up the left side of the arrow and the right side of the arrow with a line. And then I drew in a equal sign, okay, because we need those masses to equal out to each other. So then I'm just going to organize the information that I know. So it says that there's 200 grams of calcium carbonate. So I'm just going to put my 200 grams down here underneath the calcium carbonate. Then it also says there's 88 grams of carbon dioxide. So I'm going to place 88 grams underneath the carbon dioxide there. So what we're trying to look for is how much calcium oxide is produced, or X. Okay, so we're going to add in a plus sign, okay, because everything on the reactant side or the left side of the arrow needs to equal everything on the product side or the right side of the arrow. Okay, so now we have just this simple solve for X. So 200 grams equals X plus 88. So we just got to subtract that 88 on both sides to get X by itself. Okay, so that we get the mass of calcium oxide is 112 grams. Okay, so you're just figuring out kind of that missing piece and making sure that the left side of the arrow and the right side of the arrow are equal to each other. Okay, I'll do this first one as well. Okay, so hydrogen and oxygen react chemically to form water. How much water would form if 14 grams of hydrogen reacted with 34.8 grams of oxygen? So we have this reaction where 2 moles of hydrogen are adding to 1 mole of oxygen to produce 2 moles of water. Okay, so first step is to split up the left and the right side of that arrow. So we want both sides to equal each other. Now we're going to write out the information that they gave us. So they tell us that there's 14.8 grams of the hydrogen. So I'm just going to write down the 14.8 grams underneath the hydrogen. And then it also tells us that there are 34.8 grams of oxygen. Okay, I'm going to bring down that plus sign because it's going to be the hydrogen adding to the mass of the oxygen. And then we just got to figure out what mass of water is going to be produced. So that's just going to equal this left side. So we just want to do 14.8 plus 34.8, okay, which gives us 49.6 grams. So 49.6 grams of water is produced. Okay, so it's pretty straightforward. One thing to mention is don't get confused with the coefficients. Okay, for these questions, just ignore them. Pretend they're not there. Okay, so we're just splitting up the left and right, and we want them to equal each other.